Hello, this is Dr. Nair again, and I'm going to work through Chapter 3 worksheet. First question is asking, name the following alkanes. So, as we have learned the rules, we have to check which side to start numbering from. The rule is that you should give lowest number to the first substituent. So in this case, we will number from this end, 1, 2, 3, 4, 5, and 6. And then at the third carbon atom, there is a methyl group. Okay, this is a methyl group, CH3. So this compound will be named as 3-methyl. And since it is a 6 carbon atom chain, it will be called as hexane. The next one is again similar, but we have now two substituents. So this time we start numbering from the left side, so to give the lowest number to the first substituent, and this will be called as 2, 3, because at the second and third position there is methyl group, then a hyphen, and then since there are two methyl groups, we will use the prefix di, and then methyl 5 carbon atom parent chain is called as pentane. Okay. This one, you can start numbering from this end, 1, 2, 3, and 4. Second position, there is a methyl group, so it will be 2-methyl. Since it is a 4 carbon atom chain, it will be butane. Now, if you look at D and C, they both are identical compounds, and we can make sure that they're identical by again naming them. This one will also be 2-methyl butane, right? 2-methyl butane. So the best way to make sure that your compounds are identical or different is to give them the IUPAC nomenclature. Now in this case, the E, the last one, here you will start numbering from this end, right? Because 1, 2, 3, 4, 5, 6 is a 6 carbon atom chain. It will be 3, 3 dash dimethyl hexane, right? So this is how we name the examples that are given in this. The next question is asking you to draw the structure of the following: 3,5-diethyl 2-methyl heptane. So in this case, since it is a heptane, we will have to make a 7 carbon atom chain. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and 7. Okay, and then at the third position, we have an ethyl group, and then at the fifth position, we have another ethyl group. Okay, and then at the second position, there is a methyl. So this completes the drawing of this molecule. Next question, 3-ethyl 2-methyl pentane. So it's a pentane. So you go ahead and draw a 5 carbon atom chain, 1, 2, 3, 4, 5. At the third position, you have an ethyl, and at the second position, you have a methyl. So this will be the structure of the given compound. Question 3 is asking, why is it wrong to name a compound 3-isopropyl hexane? So let's draw what is given. So hexane means again 6. 1, 2, 3, 4, 5, 6. And at the third position, there is an isopropyl. If you recall from the lecture, isopropyl is this substituent, correct? Alright, so why is it incorrect to call this compound 3-isopropyl hexane? Because actually, if you number this compound, from this side it is 1, 2, 3, 4, 5, 6. So the rule in IUPAC nomenclature is that you should choose that chain which gives the largest number of substituent. So instead of using the chain which I'm highlighting as the red color, okay, so you will not use the red colored chain as the parent chain. Instead, you will use the blue colored. Okay, so this is my blue colored chain, that as my parent chain, because that gives two substituents on the chain, and that is the correct way of numbering them and naming them. So it will be called as 3-ethyl, see 1, 2, 3-ethyl, 2-methyl, and it's still a hexane. Okay? So that's the reason why it is incorrect to call it as 3-isopropyl-hexane. Next question, which of the following compounds are constitutional isomers? Constitutional isomers are compounds which have the same molecular formula but different structural formula. So if you look at A, we have 1, 2, 3, 4, 5 carbon atoms. Okay, so and then there are total number of hydrogens. So let's write down the molecular formula of the compound A. Okay, A has molecular formula C5H12. Okay, let's look at B. It has 1, 2, 3, 4, 5, right? B is C5H10. So A and B cannot be isomers, because for isomers you need to have the same molecular formula. What about C? 1, 2, 3, 4, 5. C has 5 carbon atoms, and then let's count the total number of hydrogens. 3 here, another 3 here, 6, 1 here, 7, 2 here, 9, and 3 here, 12. So this one is also H12. So it looks like A and C can be isomers, but let's finish up with D. How many carbon atoms? 1, 2, 3, 4, 5, 6. So D has 6 carbon atoms, which itself tells me that it cannot be isomer of any of these. And we have 14 hydrogens, right? So the only two isomers in here, constitutional isomers, are A and C. Okay, next question is asking to find the relationship between the two pairs of compounds that are given. So if you look at the first one, here again, the best way to check if they are isomers is to check the molecular formula. If they are the same, then they have to be isomers. And constitutional isomers differ by their structures. Okay, so for example, this one, if you look, there are 1, 2, 3, 4, 5, 6 carbon atoms. This one also has 1, 2, 3, 4, 5, 6 carbon atoms. The only difference is that this is the methyl group is at the third position, and here the methyl group is at the second position. So this one will be constitutional isomer. So B, because B is my constitutional isomer choice. The next one, if you look, they are two different compounds, right? See, we have a CH3 here and a CH3, but here we have CH2, CH3. So the answer here should be C, which is neither. The next one again is just the same compound. So this is 1-methyl cyclohexane. This is also 1-methyl cyclohexane. So it should be A here. They're identical compounds. And finally, we have two different compounds, but we have the same molecular formula again. See, we have 1, 2, 3 carbons, C3. How many hydrogens? 6. And then oxygen, 1. Here in this molecule, here again we have 3 carbons. Sorry, 3 carbons. Then we have 6 hydrogens, right? 3, 4, 5, 6. And then 1 oxygen. So they both are same molecular formula, so they should be isomers. And since they differ in their functional groups, this is a ketone, okay, this is a ketone, and here we have an aldehyde, okay, so this is an aldehyde. So that makes them constitutional isomers again, so the answer should be B. The next question is draw the molecule 3-methylpentane viewing along the C2-C3. So this is a conformation question, and you have to construct all the 6 rotational conformers using Newman projection. Okay, again remember Newman projection is where you represent the front carbon atom with a dark circle and the back carbon atom with a empty circle. Okay, and then you attach all the substituents onto the carbon atoms. So first let's draw the skeletal structure of this compound. 3-methylpentane would be drawn like this. At the third position you have a methyl group, and then they are asking us to look through C2C3. Okay, so if this is 1, 2, 3, 4 and 5, so we have to look through C2C3. Okay, these are the 2 carbon atoms. So our I is here, so you have to look through here. Okay, so let's see what are the groups that are attached to these two carbon atoms. So the back carbon atom, which we can call it as, which we can represent in a blue color, has a methyl group, an ethyl group, and a hydrogen. Okay, and then the front carbon atom, which is represented by red color, has a methyl group and two hydrogens. Okay, so let's draw this out. So I'll start by any random conformer, doesn't matter which one. This is my front, and the back is the blue one. So here's my blue carbon atom. In the front carbon atom, I have a hydrogen, another hydrogen, and a methyl group, right? So we can put a CH3 there. Then at the back carbon atom on the blue one, I have an ethyl group, which I can actually write it as ET to stop any crowding, all right? And then I have a methyl group, which again I can write Me for methyl, right? I'll write it here. Me stands for methyl, and Et stands for ethyl. Ethyl. So I have an ethyl group, methyl group, and a hydrogen. Okay. Now I do a 60-degree rotation to give my next conformer, okay, which would be again the blue carbon atom. Is the one which I'm going to move. Let me finish drawing the red one. So my front carbon atom, I'm going to keep it intact, not move it. So this is CH3 here, right? And then the back carbon atom, when I move, I have the ethyl group coming here, the hydrogen going behind this, and then the methyl group coming here. So this is my staggered. The first one is my staggered conformer, and the second one is my eclipsed conformer. Eclipsed conformer. Then I do another 60-degree rotation, and then I end up in the next conformer. So I'll keep the blue intact, the red carbon atom intact. I have the hydrogens, CH3, and then the blue one, where now I move it again a 60 degrees. So now my methyl comes here, methyl, okay, and this is my ethyl, and here is my hydrogen, okay, and keep on drawing the next conformer, keeping my red carbon atom intact. So I have the hydrogen, and then the CH3, back carbon atom. Now since I moved 60 degree, now my methyl is behind this methyl. This is also methyl, okay? And now my ethyl is behind the hydrogen, and this hydrogen is behind this one, okay? And then we move the next one, and we have the hydrogen, another hydrogen, okay? Then the CH3. We have this guy here, the blue carbon atom. Now we move the methyl moves here. We are doing a clockwise rotation every time, okay? The ethyl moves here, and now we have the hydrogen, okay? And finally, I will do the last one, where this is my eclipsed. Not changing the positions of the groups on the red carbon atom, but only rotating the blue carbon atom. Now I have methyl here, then I have the ethyl here, and I have the hydrogen here, okay? So every time I have a staggered, eclipse, another staggered, then we have eclipsed, then I have another staggered, and finally the eclipsed. So we have to pick the highest and the lowest energy conformer. Which one do you think is the lowest energy? It has to be one of the staggered. Out of the staggered that is given, the structure where the methyl and the ethyl groups are opposite to each other or anti to each other, which is this one, right? This is my most stable, but with least energy. Okay, when I say most stable, it means that has the least energy. And which one would be the highest energy one? Where the methyl and ethyl are eclipsing. It has to be an eclipse one, but the structure where the methyl and the ethyl are eclipsing, which is this one, right? So this one would be my the uh, the one which has the highest energy, but is the least stable. Okay, so that's how you label them. This one is my highest energy one, eclipsed, and this one, the standard one, is my lowest energy one. Alright, the next question is asking you to draw the skeletal structure of 1-chloropropane, and then looking along the C1, C2, you have to draw the anti-gauche and the two different eclipsed conformations. Okay, so if it is chloropropane, this is the structure of chloropropane, 2-chloropropane. Sorry, 1-chloropropane. So we have chlorine here, right? And then you have to look along C1, C2. So if this is C1 and this is C2, you are keeping your eye from here. Okay, this is how you're looking. So the groups attached to it are a chlorine, a hydrogen, let's erase this one. So we have a hydrogen and a hydrogen, and then at the back we have a methyl, hydrogen, and a hydrogen. So the front, so they're asking draw an anti-conformation. So for that, you should have the chlorine and the methyl group here, right, at the opposite. So if we draw the front carbon atom like this, then at the back carbon atom, the methyl group should be here, anti-conformation, okay, and the two hydrogens. So this will be the most stable conformation and the least energy, that has the least energy. And then it's asking you to draw a gauche conformation. Remember, gauche means when the chlorine and the methyl are right next to each other but in a staggered conformation. Okay, so the way we will draw this is we'll keep the chlorine and the hydrogen carbon atom intact, and then you'll have your CH3 group here, the hydrogen here, and hydrogen here. Okay, so this is a staggered, but since the chlorine and CH3 are right next to each other, it is called as a gauche conformation. Then it's asking two different eclipsed. So the two different eclipse conformations will be one where the chlorine is actually eclipsing the methyl group like this. The hydrogens are right behind this. And then the other one would be where the chlorine is actually eclipsing a hydrogen atom. Chlorine is eclipsing a hydrogen atom. The methyl is over here, and then the other hydrogen atom is over here. Okay. So these are the two eclipsed conformer. The one where the chlorine and the CH3 are eclipsed with each other, that will be the least stable or the highest energy one, okay, because of the close interaction between two large groups, chlorine and CH3. Now this question is asking you to identify functional groups, which is the first thing you studied in chapter 3. You should know all the important functional groups. Like carboxylic acids, ketones, aldehydes, amines, amides, okay? Alkenes, arenes, alkynes. Then we have the esters, ethers, alcohols. Okay? So I expect that you would know this functional group pretty well, because later on in all the chapters we'll be using functional group chemistry quite a lot. All right, so to identify, this one is actually a carboxylic acid. Carboxylic acid. This one is a ketone. A C double bond O is a ketone. This one is an alkene. Here we have an amine, arene. Okay, benzene rings are referred to as arenes. We have a halogen or a halide. This is also an amine, and this one also will be a amine. This is how you identify all the functional groups in this molecule. The last one is regarding the intermolecular forces of attraction, helping us to um, discuss the boiling points of different alkanes. Actually, this question is more regarding the structure. So if you look at which will have the highest boiling point, heptane, 2-methylhexane, 2,3-dimethylpentane, 2,2,3-trimethylbutane, and all have the same molecular mass, would have the same boiling point. So it's a choice. You have to pick up the correct choice. So here the correct choice is heptane, because when you have the branching in the molecule, then they reduce the surface area, and it lowers the boiling point. So heptane would be a straight chain like this, right? 1, 2, 3, 4, 5, 6, 7. Whereas 2-methylhexane would be where 1, 2, 3, 4, 5, 6. This is 2-methylhexane. 2,3-dimethylpentane would be this one, right? And 2,2,3-trimethylbutane would be 2, 2, 3, this one. So as the branching increases, the boiling point will start decreasing, because you can see that the surface area decreases. This is the one which has the highest boiling point, because it has the London dispersion, a large amount of London dispersion forces compared to the rest of the molecules. Okay? So that finishes up the worksheet number for chapter 3. And I hope you practice some more from our active homework as well as end of the chapter problems. See you in the next video.